some techniques too that you need in order for you to identify such graph quickly. Alright, so the first one we want to look at is a circle and what? Spiral. Let me first go straight to the spiral because the spiral is only one here. The spiral is r is equal to a theta. R is equal to a theta is the same as where a is a constant. A is a constant, so it can be r is equal to 2 theta, 3 theta, 5 theta. All those are going to be what? Spiral. But here is for positive spiral. You see here is positive. So if it's positive, it will start like this. But if here is negative, please take note. If here is negative, that one too will start like this. Then it go like that. I hope it is clear. So if it's negative, it will be like this. If it's positive, it will be like this. Alright, so those polar equations are what? Spiral. Now, these dots, they are all circles. For instance, r is equal to a. Like r is equal to 5, r is equal to 2, 3, 4, 5, 6,000, 7,000. They are all going to be like what? A circle. Alright. Now, let's look at the relationship between sine theta and cos theta in polar equations. Now, I will be quite small about the a here. I'll talk about it later, right now. Alright, but let me first talk about the sine theta and the cos theta. You see that this is on a Cartesian plane, right? X and y what coordinate? Plane. But here we are talking of r coordinate and theta what coordinate and all that. Okay. So we have positive x-axis and negative, positive x-axis and negative what? X-axis, positive y-axis and negative what? Y-axis. So if sine is positive here, if the sign here is positive, it means that this is going to be on the what? Positive what? Y-axis. That is the sign. But if here is negative, so it's plus or minus. If it's negative, it's going to be like this. So that means that the negative will be will reflect on the what? On the negative what? Y-axis. Alright. Now looking at what is here too is the same thing. The negative will be here and the positive will be here. This is on the cos. So the cos means that the polar graph is going to be on the x-axis. But the sign attached to this will let you know whether it's going to be the positive y-axis or x-axis or the negative what? X-axis. So this is what this technique is telling us today. Alright. Good. So let's go to the second polar equations or the nature of it. Alright, so I'll be back. Alright, welcome back. So the second one is, welcome back to the second one. So 2, that is lemma, please. Before I mention the word, please, it's a French word. Alright, it's a French word. The French people will help us to say it well. But people call it lemma-cons. Some people say lemma-zons and all that. But this one is like C and there's a slash here. So I normally say lemma-cons, lemma-cons, lemma-cons. Alright. Choose the one that you think you can spell, okay? So it is in this form, okay? It is in this form. But the A should be greater than 0 and the B should be greater than 0. So generally, you cannot get the A and the B to be 0. Always is greater than 0. Alright, because if it's 0, everything will vanish. Alright. Now, the sign of the sign, whether plus or minus there, gives the orientation. We have already discovered that the sign attached to the sine or cos show whether it's going to be on the x-axis or on the what? The y-axis. So this one that you have here, it's not that it's here or y doesn't mean that always it will be on the y-axis. It depends on the trigonometric function you are what? Using. Okay? Alright. So I'm just using this as an example. So if it's negative, you know where it's going to be. We have already discovered that and all that. Now, you can compare this one here to the first one that we talk of. R is equal to a sine theta, cos theta, and all that. You can see that here is gaining another value here. It's gaining another value here. When you close this one, it's something like what we have just done. But when you remove your hand, you can see that there is something coming in here. And that is going to change the nature of the polar graph. And you will love it. Alright. A. That is when this A is less than the B. So when the value here is less than the value here, then we get Lec4 with what? Inner loop. And that is how it's going to be the inner loop. The inner loop here is the minimum and here is the maximum. I'll talk about it. Alright. This also when the A is equal to what? B. That's what we call what? Cardinal. And that one to here is the minimum, here is the maximum. I'll talk about it. Alright. Let's continue. Now, they see that's the minimum, that's the maximum. This is when A is greater than B. So when A is greater than B or B is less than the A, you will see that it will end here. This is at the origin, this at the inner, and this here. So no the difference. And the converse one too. When A is greater than or equal to what? 2B, or half A is greater than or equal to what? B. Alright, that is when you multiply A by half and it's greater than B, then we say it's going to be what? A convex. Alright, so let's talk something about it. Now, the first one that was forming circle, that is the cos and the sine one. You can see that, for instance, you have R is equal to A sine theta. We are saying that it's going to be on the positive what? YR is right, and it's going to be a circle too. Now, take it like that. This circle, the maximum is always going to be the A here. What is here, the A is going to be what is here. And the same way, that's going to be the what? The A. And you are going to get it to be what? A circle. Like that. Now, can you also say that this one, the maximum is going to be the A? No. Here we are going to get a maximum and a what? And a minimum. So let me teach you how you can use this idea so that without even you coming out with that table, that long table, from 0 to 2 pi or from 0 to pi, without you even coming out with that table, you can even sketch it yourself and go your way, because we are moving from here, we are moving to another steps. Alright, so let me give you the technique. I love you, and I always want to give you the rest. Okay? Let's first talk of the maximum. Then let me talk about the minimum here. The minimum. Alright. Now, the maximum is always A plus B. For you to determine, you know that, for instance, A sine theta, R is equal to A sine theta. The A there is a constant, and that is just showing how enlarged the circle is going to be, or how enlarged your graph is going to be. So we know that the maximum is always telling us how enlarged it's going to be, because we know that R is equal to sine theta is going to be like a circle. R is equal to 3 sine theta is also going to be like what? A circle. But know that this one will be large. The alignment of this one is not going to be like the same as the sine of theta. Alright. So, coming back to this, R is equal to A plus or minus B sine theta. R is equal to A plus or minus B cos theta. Alright. So let's talk something about that. Now, the maximum is A plus B, the minimum is A minus B. Again, with the maximum and the minimum, please listen, please, I beg you, listen to this one. The maximum and the minimum. The plus or minus here don't come in. Because we know that the plus or minus there is just giving you the orientation. Whether it's going to be on the x-axis or the y-axis or where. That is where the plus or minus is telling you. So the maximum is going to be a plus b. The minimum is going to be what? A minus what? Minus b. So for example, let's say you have this question to sketch. First, you know here is positive, right? So that means that sine is y-axis, so that means you be on the y-axis. But you don't know whether it's this or that. You don't know. So how will you know it? That is the concept. That is all that we want you to know. How will you know it? Simple. The A is 3. The B is 2. So that means that A is greater than what? B. So if A is greater than B, beautiful. So that means that it's going to be what? A dimpled lemma form. A dimpled what? Lemma form. But you have to know your maximum and your minimum. So how will you know the maximum? To know the maximum is 3 plus 2, which is 5. That means that on the graph, this is going to be what? 5. Beautiful. Alright. And how will you know the minimum then? So the minimum is A minus B. Please, don't change the position. A minus B is not the same as B minus A. A minus B, so 3 minus 2. And that's going to give you what? That's going to give you what? 1. So that means that here, your minimum is going to be what? 1. So, if you know here is 1, without drawing a table, you can sketch. You just start at the one here, go like this, go like that, and go your way. You know here will be 5, so you just enlarge this one small, you just enlarge this small, and you go your way. Okay? Alright, so that's the technique. That's the techniques. Alright? Let's look at another example. R is equal to 1 minus 2 cos theta. So first of all, you know that this is cos, so S is right. So the negative means that it will be on the negative what? S. But you don't know whether it's this or that or that. So let's see. A is 1, B is 2. So A is less than B. A is less than B. Oh, it's going to be what? Element 1 with inner loop. So go for the minimum. So the minimum is going to be 1 minus 2, which is negative 1. That means that here is going to be what? Negative 1. And 1 plus 2 is 3. Sorry. Oh. The minimum is what I did first. So the minimum is 1 minus 2, which is what? Negative 1. So that means that the minimum will be here. So the maximum is plus. The maximum is plus. So that means that here is going to be what? 3. So that means the maximum will be what? 3. I hope you love it. Alright. So you can, that's how you do it. Just simple. So what would this be? Just tell me, says. So let's see. 2 plus 2 cos theta. 2 plus 2 cos theta will be what? You can see that A is equal to what? B. So A is equal to B. That is a cardboard. And the minimum is what? 0. That is why it will be at the origin. I love it. And the maximum is going to be A plus what? B. That means that here is going to be what? 4. So the enlargement of it is going to be what? 4. Wow. See you for the last technique. Bye-bye. Alright. Let's look at the third one. That is rows. Roses. Please, I don't know if I have a rose watching me right now. Roses. Okay, so the roses is in this form. Okay, you see that the first one, the first technique is something like R is equal to A sine theta, A cos theta. You need to see something like 2 theta or 3 theta or 5 theta, or how we can see that, or 1,000 theta. Alright, so let's see the case where we have such things. Alright, so n leaves. So the n leaves if n is odd. So be careful. If the n here is an odd number, that means that it's going to be n leaves. The leaves are this. These are the leaves. These are the leaves. Okay. So if n is odd, it means you get how many leaves? N leaves. 2n leaves if n is even. So if n is even, that means that you are going to get 2n what? Leaves. That means that you multiply 2 by the even what? Number. So looking at the example we have here, the first one is A cos 2 theta. You know that the A here is just telling you how enlargement is going to be. Don't worry. So please, this one is like 4 cos 2 theta. What is this? This is the n. And the n here is what? 2. Is 2 even number or odd number? Even number. Alright. So if the 2 is even number, that means that you have to multiply by what? 2. So 2n give you 2 times 2, and that is 4. So it means you are going to get 4 what? Leaves. So 4 leaves. 4 leaves what? Rows. So one will be here, one will be there, one will be there, one will be there. That's how it's going to be. Here, A cos 3 theta. Alright. So the 3 there is what? Odd number. So since it's an odd number, and you know cos is always at S axis, so you are going to get 3 leaves. So the first leaf will be on the positive S axis, so that the rest will be here. 3 leaves. So this is just 3 leaves. It's odd. Don't multiply by 2. Here is 5. The argument is 5 theta. So here, since it's cos, you get 1 here, 1 will be here, 1 will be here, 1 will be here, 1 will be here. That's how it's going to be. Alright? So you can try on R is equal to A cos 4 theta. So now, how many rows? 8. 8 rows. So even if you draw the table, you have to have this in mind so that you know where you want to what? Get to. So this is what? 8 what? Rows. So you see it's going to be something like this. The first one will be here, 1 will be here, 1 will be there, 1 will be there. Then 1 will be here, 1 will be here, 1 will be here, and 1 will be here. 1, 2, 3, 4, 5, 6, 7, 8. So that's how we are going to get it. Alright. Let me come back with the last technique, that is lemniscates. It's not biscuito. I'll be back. Yeah. These are things that we have sketched before here, and we are now giving the names to it. Alright, so this is the fourth one. Lemniscate. So the lemniscate is in this form. Alright? The lemniscate is in this form. Please, here is square. Here is square. So it will be this, or R is equal to square root of A squared sine theta. R is equal to square root of A squared cos 2 theta. Alright, so that's the lemniscate. So if a sine, you see this and this are the same thing. The A is just telling you how a line is going to be. I've told you already. So the A is just the last part. The A is just this. That is that. Alright? So now, if a sine, it will be like this. Okay? It will be like this. And if it's cos, so just be on the S axis like this. But this will not be on the Y axis. It will be something like that. Alright, so you just have to know the nature and the name given to it, and the condition for all that we have done is very necessary. See you